I have this little spring-loaded launcher. When I pull the trigger up, the spring is going to shove that ball that way. It's going to drop the weight down. Which one do you think is going to hit the ground first? Hey, it's a tie. Now, how could that be a tie? This guy only has to drop straight down. That's a lot shorter than this guy going all the way out. What makes them fall to the floor? Gravity. And they both have the same distance to drop. The horizontal velocity is just going to carry the ball further out. And this will be true even if it's for a gun. As long as it's fired horizontally, the bullet and the weight would drop to the ground in the same time. Still not sure? Try this demonstration. Take a ball and just drop it into your hand. You see it going straight down. But what if I was walking and doing it at the same time? So here we go. What did you actually see? You saw the ball release from here, but it landed in the hand over here. So you saw it actually forming a curve. What did I see? I'm keeping up with the ball. So when I let go, I just see it drop straight down. Which gets to my hand first? Hey, it's got to be the same. There's only one ball. So you can do this on a school bus. You're driving along and you toss the ball into the air. Where will it land? Right back in your hand. You're moving along with the ball, with the bus. But what does somebody see from the sidewalk? When you throw the ball into the air, you're also moving sideways, and the ball to them looks like it's on a trajectory. And it lands back in your hand because you're moving along with it. I know you still doubt me, so I have this cool little cart. We're going to launch this steel ball out of this thing. It's spring-loaded. When I pull the pin, the ball shoots up. Let's see what happens when it rolls. Okay, it's set. Well, the aim is off, but the horizontal motion worked out. When the ball is released, it has horizontal motion and it stays with the cart. How about something a little more powerful? Our projectile motion launcher. It's spring-loaded. We can launch this ball. There's a catch and a trigger, and we can change the angle. I've got it set on 0 degrees. It's going to shoot horizontally. I've got a clamp to the table. From the floor to the bottom of the ball is 115.7 centimeters. We got the meter sticks laid out and we're ready to go. I've done a few trials now, and I'm getting some random error in here a little bit, but it's about 217 centimeters. So now you know what the range is experimentally. We also know what the height is. Your goal is to find the initial velocity of that ball. All right, you got the velocity of this thing? Because now we're standing it up vertically. We're going to launch this ball straight up. You have to predict how high up that ball will go. I'm not pulling the trigger until you do the calculations. Well, how'd you do? Did you get about a meter? Well, if you got the last one right, let's move on. What would happen if we launched it at a 30-degree angle? If you know the velocity, you should be able to figure out the range. To land on those books over there, which have been set up to be the same height as the launcher. I measured with the meter stick. So go calculate the range, and then we'll see if you're right. Here we go. And now I've got the meter sticks lined up so we can measure the range. Okay, it's about 170. Well, now we're going to try for a steep angle. 60 degrees. You do the math, make a prediction where it's going to land, and we'll try it out. Did you get an interesting answer? Let's see. Oh my gosh, for real. It's just about the same. Okay, what's that mean? At any angle it goes the same range? I don't think so. Let's try 45 degrees. Well, that shot right over the books. Okay, look at the meter stick and see if you can find the range. Just one more experiment to go. Let's launch it at 30 degrees again, but this time onto the floor below. We are 116 centimeters above the floor, launching downrange. How far is it going to go? Well, depending on the run, I'm getting about 273 centimeters. I hope you were close.